The Aisin AX15 transmission was popular in Jeep models built between 1989 and 1999. It was also used in the Dodge Dakota pickup trucks. Similar versions are found in General Motors and Isuzu trucks, and also some Toyota trucks. Parts for this rear-wheel drive transmission are still readily available from both dealership and aftermarket sources. This 1990 AX15 unit will serve as our prototype for the rebuild. The front view reveals the vintage of this AX15. Note that up through 1992, the AX15 uses an internal slave cylinder or release bearing. The front retainer has no provision for a conventional release bearing, and in this build-up, we'll install a new iron retainer that works with the 1993 up external slave cylinder, clutch housing, and mechanical release arm mechanism. This is a simple, purposeful changeover. The rear view of this AX15 shows the characteristic 23-spline output shaft. On the YJ and TJ Wrangler AX15 applications, and also the XJ Cherokee, the output shaft extends nearly 1/2 inch beyond the rear face of the transmission extension housing. The NV3550 is typically an output shaft that ends flush with the rear face. The AX15 must mate to the correct transfer case input gear. For an Advanced Adapters Atlas II transfer case conversion, the output shaft of this AX15 will require slight shortening. This step will be highlighted later in the rebuilding details. This is the shift tower. On AX5 and AX15 units, you can reach above the tower when the transmission is in the chassis, raise the shift boot, press down on the spring-loaded retainer, and rotate the retainer counterclockwise to release it from the 2 pins in the tower. The shift lever lifts out readily once the spring-loaded retainer is loose. Inspect these parts for wear. Replace the old bushing at the lower tip of the lever. This bushing wears out or becomes brittle with age. Now the rebuild begins. Follow these steps closely for a quick, safe disassembly. Start with loosening the shift arm retainer bolt. Hardware is all metric on these transmissions. Remove the 2 restrictor pins. These pins come loose readily. They have a spring-loaded ball bearing at the inner end and play an important role in limiting and tensioning the shift lever movement. This is where shift feel begins. At the front of the transmission case, loosen the shift lever shaft plug. This hex insert is 10 mm metric. Use the correct tools to prevent damaging hardware. A stripped insert hex plug is extremely difficult to remove. Replacement parts may not be easy to find. The right tool will protect your transmission and ease the task. The shift lever shaft is generally easy to remove. A shop pickup magnet works well for catching the end of the shaft and sliding it out. The shaft should move freely. Do not force precision fit parts. Note the oil hole in the shaft's outer end. Now the shift lever shaft and shift lever arm are free. Inspect the contact surfaces for wear and damage. This is a durable setup. The transmission has well over 200,000 miles on it, and this is the original shaft and arm. Still reusable. The Aisin AX transmissions use several detent plugs with springs and balls. Interlock plugs and balls regulate shifts and prevent grabbing 2 gears at one time. A good idea. During disassembly, you will need to account for the access plugs, springs, and the interlock plugs, pins, and balls. Removing these pieces in sequence will prevent damage and permit shafts to move readily out of position. Here, we remove this plug with spring and ball. Remove the extension housing case bolt that secures the wire bracket for the backup light switch. The backup light switch is now ready for removal. Use the correct wrench and protect the wire during removal. This switch still works after 20 years of service. Now you can remove the rest of the extension housing bolts. Carefully circle the housing to make certain you have located each of the 10 bolts. Never force parts. If you remove all of the extension housing fasteners, the case will separate properly. Note the length of the bolts and where they were fitted. You should now be able to tap the extension housing rearward. This unit has sealant adhesive on the mating surfaces, and breaking the seal requires carefully tapping at the flanges. Rearward of the hammer, there are small triangle tabs designed for tapping gently. If this does not work according to plan, tap at the heavier extension adapter flange to avoid damaging or breaking the wing tabs. Do not use excessive force. This is aluminum. Once the seal is broken, the extension housing should slide rearward. Keep the housing level and slide it loose carefully. Do not force any pieces and avoid binding the parts. This is a precisely machined assembly and should be handled properly. Aluminum scratches readily, gouges, and can even break if mishandled. tough material when installed properly, these housings hold up very well over time. With the extension housing free of the intermediate plate, you can place the housing on the bench. Place the housing with the seal and rear face upward. Pry or drive the old seal out. If you use a pry tool, do not gouge or scratch the aluminum. The seal will come loose readily. All retainer bolts removed, gently pry the front retainer plate away. Always brace against a surface that will not become damaged. Again, this is aluminum, so use extra caution. Force needed should be minimal. Drive the seal out of the retainer. A socket and plastic sandhead hammer is a good tool for this task. The seal will come loose readily. Japanese and European seals have a different style jacket. Seals install and come out easily, stay put, and seal well for a long time. With the retainer out of the way, the front bearing and its snap ring are visible. Use a bill-type snap ring pliers to spread the snap ring. Spread rings evenly. Minimize distortion by only opening the ring enough to clear the groove. The Aisin transmissions use selective fit snap rings in several locations to align parts, set end float, or establish gaps and clearances on precision fit parts. Always identify and match up the location of these rings. Measure their thickness with a micrometer or accurate dial caliper. Remove the front counter gear snap ring. The procedure is the same for this flat snap ring. Ends are easy to grasp with this type of snap ring pliers. Buy a good pair. This heavy-duty New Britain set is 33 years old now and still working. I like the design for transmission work. Today, Stanley Proto makes a quality replacement pliers. Tap at the flange tabs and carefully break the sealant seal at the intermediate plate. You want this intermediate plate to separate smoothly and straight. Do not bind up the parts during this important step. Even after years in service, this AX15 comes apart without a fuss. Note that the support for this transmission is from the front face, using the Mark Williams Enterprises bench mule as a stand. The entire gear assembly will move outward with the intermediate plate. Support the plate and gear set to keep the assembly level. Tapping lightly at the input nose and the counter gear with a plastic hammer. Make sure the assembly slides rearward with the input and main output shaft gear sets plus the counter gear all moving together. Note that if you do not have a fixture like the bench mule, you will need to support the transmission in another way. The typical method for supporting the intermediate plate is a bench vise with protective rubber or aluminum covers over the jaws. Do not gouge or mar the aluminum of the plate. There is a good deal of weight on the intermediate plate. When the input shaft bearing and counter shaft bearing clear the front face of the transmission, the entire gear assembly can be safely removed. Do not drag parts against delicate aluminum bores or casings. Keep the gear sets together and aligned. Lift the gear sets free. Be cautious, this is an awkward assembly to handle. You'll be glad you have the bench mule or something similar. This stand is more than a decade old and still highly functional. A great shop asset, especially if you work alone. Again, this is the Mark Williams bench mule. Gears and shafts in alignment. You can see the relationship of the counter gear to the input main shaft gear sets. Note that the entire gear train is still intact. Despite complexity of this assembly, the whole unit came free from the front case without difficulty once the appropriate parts were removed. The AX15 is a busy transmission. Note the shift rails, forks, gear sets, intermediate plate, and small parts. On the edge of the intermediate plate, the plugs align for the shift rail balls, springs, and interlock plugs and pins. Plugs make access and service quick and practical. Plugs removed with a Torx bit socket. You can now use a magnet to access and extract the springs, balls, and interlock plugs. Again, proper tools are necessary for removing parts. While not expensive, tools like the Torx bits and metric Allen sockets make this work easier and prevent damage to the transmission parts. 2 screwdrivers placed evenly at the snap ring will enable a light hammer blow to drive the snap ring loose. Although using a blade and Phillips screwdriver here, the better approach is a pair of matching blade screwdrivers. Use a plastic head hammer to prevent tool damage. Expect the ring to come off with force. Wear eye protection. When possible, move the snap ring this far out of the groove. Now you can place a blade screwdriver in the gap. Twist or pry the snap ring loose. Again, avoid damaging the snap rings, as they must be intact for measuring thickness. These are selective fit and cannot be mixed. Note the location and thickness of the ring. 2 bolts hold the reverse shift arm bracket to the intermediate plate. You can loosen the shift arm's E-clip retainer first, whichever is easiest. Here, I loosen the bracket before removing the E-clip. Now you can see the E-clip. Pry it loose with a screwdriver in one of the slots, and you can then detach the shift arm from the shoe. The shoe rides on the shift rail. The shift arm is now free. The shoe hangs loose from the rail. Once again, these parts must come loose in sequence, and these steps precede the next series of tasks. Follow the sequence to correctly tear down and assemble this unit. Remove the 5th gear fork set screw. Note that this is a metric socket. Follow the sequence, using the correct tools for each task. Slide and remove the 5th gear shift fork. Do not force parts. You may need to slide parts out of the way. The fork should come loose without much effort. Remove the reverse shift head and rail. This comes out as an assembly. There is no need to disassemble the shift head from the rail. Here, I am placing the jaws of a 2-jaw puller behind the 5th spline gear. The gear also has 2 bolt holes at its face for use of a slotted rail or damper type puller. This gear takes force to remove. If you use a hand wrench or socket and ratchet to rotate the puller stem, keep the puller's jaws from rotating to prevent damaging other parts. I choose to lubricate the puller stem with high-temp grease to prevent friction damage and carefully rotate the stem with a deep-set impact socket and my air gun set at light pressure. Wear goggles when applying impact force. The complete counter 5th gear and synchronizer assembly is now free of the counter shaft. The gear and spline piece are not damaged, and neither is this caged needle bearing. Despite the ominous appearance of a broken bearing cage, this is actually a 2-piece caged needle roller assembly. Always protect parts during disassembly. A few minutes of care may save a good deal of expense. These are precision parts. This is a 5th gear assembly. There is a synchronizer on 5th gear and a rugged pair of gears for a light-duty truck transmission. 5th gear on the main output shaft is much smaller and the most vulnerable gear in any overdrive transmission. However, the AX15 has considerable stamina and gear integrity. These gears hold up very well. This 200,000 plus mile unit is a living testimonial. Note the relationship of these parts and the directions in which the sleeves and gears were removed. Parts must go back in place in that same orientation. Behind the 5th gear you will find the 5th gear thrust and its lock ball. The thrust is extremely good material and built to last. The 5th gear on the main output shaft is visible above the thrust and counter gear. Note the width and material of these gears. Although not comparable to an NV4500 1-ton truck design, for a lightweight XJ Cherokee, YJ Wrangler, or TJ Wrangler, the AX15 is quite impressive. I'd readily put 250 to 275 horsepower in front of this unit once the rebuild restores the transmission to top condition. Remove the bolts attaching the rear retainer plate to the intermediate plate. This steel plate will readily come loose once the 4 bolts are removed. Use the flat edge of a pry tool to gently lift the plate free. The retainer plate holds the reverse idler shaft in place. With the retainer plate removed, you can slide the reverse idler shaft loose and free the reverse idler sliding gear. I inspect the reverse sliding gear inner bushing for both wear and the degree of wobble between the reverse idler shaft and the bushing. When removing the shift rails, rotate them to free up pins, balls, and interlocks. Here, I rotate and remove the 5th gear shift rail. Note that all ball, plug, and pin pieces must be removed. Place them in a safe location. If in good condition, they can be reused. Do not force rails out. If they are not moving, there is an obstruction. Rotate and gently slide the shafts to free interlock pins, plugs, and balls. Note the orientation of these parts for reassembly. Remove the shift fork set screws. Set the screws aside safely. This is all unique hardware and high-grade steel. Finding replacement parts can be difficult and costly. Reusable parts must be preserved and not lost. Here, I'm once again using the 2-screwdriver technique to loosen the C-clips on the shift rails. This is a professional method for driving the clips loose. Apply uniform pressure to each end of the ring. Beware, These clips will fly off the bench if you do not catch them. Drive the clips away from your face and eyes. Eye protection is always a good idea. A light, controlled tap with a plastic hammer head will do the job. This is the last of the 3 C-clips. I can generally push these loose by hand without the need for a hammer. Press evenly at each end of the clip. Use flat blade screwdrivers. Rotate and remove the first, second gear shift rail. Watch for interlock pins and small parts at the plug holes. Find the position of the rail that will free up the locks and allow the shaft to slide out freely. Never force these rails loose. Reassembly of parts is in careful sequence, as outlined in part 2 of this video. Keep track of small parts, plugs, interlock pins, balls, and springs. These pieces are critical to keeping your transmission in gear. You must keep these pieces in a safe place after cleaning them. It is amazing how much delay can be created by misplacing or losing one of these small parts, then trying to find its replacement. I place small parts in a special metal basket for cleaning in my parts washing cabinet. When I sent the AX15 pins and small parts on a wash cycle, 2 small pins managed to find their way through the tiny holes in the basket. 45 psi nozzles and pressure spray had a lot to do with this. Once the machine cooled down, I spent 30 minutes with a magnet and long-sleeve glove combing the washer floor by hand. Fortunately, I found both pieces. Tiny parts can be washed separately with a small pail, solvent, and a parts cleaning brush. The third, fourth shift rail can now slide free. Rotate the rod to free up the small parts and find the point where the notches and parts become free. If the rail will not slide, something is in the way. Carefully catch forks and set them aside. Remove the locks, springs, pins, and balls with a magnet. This Mechanix pickup magnet has served me for over 35 years. It still functions well and fits neatly into the bores of transmission shift mechanisms. For transmission and transfer case work, you need a magnet like this one. Again, the Torx bit socket fits snugly into a plug head. This head atop the intermediate plate will access the bore to the lower rail. If all of these springs, balls, pins, and interlock plugs are difficult to track, do not be concerned. I will show how and where to assemble each of them in proper sequence during the assembly phase of this rebuild. Plug removed, the spring and barrel-shaped interlock plug come out. The magnet helps once more, removing parts deeper in the plate's bore. Now the reverse shift rail and fork slide out. Rotate the fork to ease removal. There should be no obstructions. To be safe, check the bores for any small parts and lift them out with a magnet if necessary. Account for all pieces. Now you can see the gear sets. This is a nice setup and very well constructed. Although busier in a service sense, built properly, the AX15 makes a very reliable and rugged transmission. Note the power flow and gear sizes. This is a close ratio 5-speed with nice, uniform spacing of the gear ratios. First, 3.83 to 1. Second, 2.33 to 1. Third, 1.44 to 1. Fourth, 1 to 1. And fifth, 0.079 to 1, with reverse 4.22 to 1. With lower, numerically higher, ratio gearing at the axles and transfer case low range, the AX15 is highly functional. Remove the snap ring at the output bearing. Use the quality snap ring pliers. These revered pliers have been ground for special application use, and I'm due for a new set soon. This pair will still serve for special uses. Look for a set like this duck-billed steel type. A quality set could last for 35 years or more. This pair has. Similar to the front of the transmission, the counter gear rear bearing snap ring is next in sequence. Snap rings secure bearings and precisely align the gears, bearings, and thrust washers. Keep track of these selective fit snap rings and their positions. Lay out the disassembled parts in order. If necessary, make notes on duct or masking tape indicating the location where the snap ring fits. Tape notes to each snap ring. Tap the counter shaft and main output shaft ends. Tap evenly. A light tap at each shaft to keep the parts moving out together. You want the gear sets to each drive through at the same time. Keep shafts and gear sets aligned. Support shafts and prevent binding or jamming of parts. Do Do not allow synchronizers or gear components to knock against each other. Take your time here. If necessary, tap the counter gear end with a plastic head hammer. This Stanley hammer has a sand-filled head and packs a great wallop when necessary. At the same time, it can deliver a modest, controlled, and deliberate kind of force capable of sliding parts like this shaft. The bearing stays in the plate as the shaft slides free. There should be no resistance between the bearing and shaft. The plate is now empty except for the counter gear bearing. Select a socket large enough to tap against the outer race of the bearing. Tap straight to protect the bore. The sand-filled plastic hammer moves the bearing promptly from the plate bore. The case, shift mechanisms, and gear assemblies are now all apart. The intermediate plate stands alone in the bench mule holding device. Here, I move to the subassembly work. Begin with measuring the clearance of gears and thrusts along the main shaft. This is a check for first gear side clearance. For first gear, the minimum should be 0.003 of an inch. The maximum is 0.0197 inch, a wide spread. Measure clearances with a blade-type feeler gauge set. Place the feeler gauge blade or blades between the thrust washer and first gear. The thrust washer rides between the rear bearing and first gear. The second gear clearance is 0.003 of an inch to 0.0118 inch, a closer spread than the first gear clearance. Use the blade feeler gauges and insert the blade or blades between second gear and the thrust surface machined into the main output shaft. The feel should be a slight drag on the blade or blades that take up the clearance. This is the side clearance of the gear. For third gear, you will press the feeler blade or blades between the main shaft thrust and the third gear. This time you will be on the third gear side of the thrust. For third gear, the clearance is again 0.003 of an inch to 0.0118 inch. If the measurement is within specification, the side face wear of the gear and the thrust will be acceptable. Note that other concerns are gear wobble or any looseness between the shaft or inner race, the bearing, and the gear. For gear runout, these same three gears with bearings in place can tolerate a maximum of 0.0013 inch measured with a dial indicator. I like to see slightly less than even this small amount, especially with new bearings. Minimum runout is 0.0004 inch, closer to the expected oil clearance reading for a new shaft, new bearing, and new gear. In simple terms, there should be no wobble felt. These were my findings noted on the bench top. The first gear side clearance is approaching the wide limit but still within specification at 0.016 inch. 0.018 inch notation was the blade that would not squeeze into the space. Second gear is better, and third gear is the best. All three gears are within tolerance, and the thrust widths have not been read yet. Note that if there is any wear at a replaceable thrust, these gears are even more within tolerance. Unless there is tooth damage or too much radial runout, which would be clearance or play, between the main output shaft, needle roller bearings, and the gears, these gears all meet factory tolerances, even at this mileage. The pilot caged roller bearing is a familiar piece in manual transmissions. This bearing supports the nose end of the main output shaft in the back bore of the input gear. The bore of the input gear, the nose end of the main output shaft, and the bearing itself each determine radial runout and shaft stability. I replace this bearing as a matter of course. Check the bore and nose end for wear and damage. Shaft alignment is crucial to transmission performance and reliability. The crankshaft pilot bearing and transfer case input gear are also involved in transmission shaft alignment. Remove the output shaft snap ring. This is the lock for the fifth gear and bearing. Selective fit, the snap ring aligns the fifth gear and positions the bearing on the output shaft. Keep these parts in sequence and make sure you know their location. You will measure the snap ring with a micrometer or dial caliper if there is a need to replace the ring. Use caution removing the ring minimize spread and distortion. The fifth gear is generally tight on the output shaft splines. If you intend to reuse the rear bearing, do not pry against it. I was able to dance the fifth gear from the output shaft with the use of my blunt-ended impact driver, applying force at the output shaft's end recess while holding the fifth gear stationary. I drove the shaft through the gear with minimal effort and no risk to parts. Easier yet is to press the output shaft through the fifth gear and output bearing at the same time. The press will remove fifth gear, the output bearing, and the first gear, all in the single operation shown here. Note that pressing the shaft through the fifth gear and output bearing at the same time, I made a fixture to support the back side of the first gear during the pressing operation. The fixture's two stands catch the gear's backside safely without risk of tooth damage. My fixture stands are tall enough to allow the shaft to press out without hitting the press deck. Fifth gear will come off with the bearing and gear. There's a caution here: when pressing the first gear, output bearing, and fifth gear loose, watch for the tiny locating pin that indexes the first gear thrust washer to the main output shaft. First gear will clear the pin as you press the shaft through the output bearing. Do not damage or lose this pin. The block of wood will catch the drop shaft. Now the thrust washer, needle bearing, plastic first gear spacer, and first gear will slide off the main output shaft. Note that the thrust washer has a square inner notch that indexes with the pin on the main output shaft. This finger press fit locating pin is removable, as I discovered the hard way. In washing all parts in my high-pressure parts washer, the pin wound up with one of the shift detent pins on the floor of the washer cabinet. Rather than lose or fish for this part, remove the pin from the main output shaft and set it aside safely. Insert plates, 3 of them, at the first gear Synchro hub are a wear item. Inexpensive, replace them if there is the slightest indication of wear. Access these inserts by sliding the Synchro sleeve reverse gear from the hub. Parts should be marked for their positions if you intend to reuse any of them. Wear patterns may create quirks in shifting if these used parts, especially the brass Synchro rings, are not replaced in their original positions. Remove the snap ring at the Synchro hub for first-second gear. The hub is important as the outer sleeve doubles as the reverse gear. Hub and sleeve wear could cause gear whine in reverse or cause erratic first-second shifting. Check hub and sleeve closely. Note the condition of the reverse teeth. Chips and damage are generally the result of grinding the transmission into reverse gear without the vehicle completely stopped. Reverse is non-synchro mesh. Drive in a manner that protects this gear. Even a reusable gear will have some wear at the engagement end of the teeth. This fixture is paying off. Here, I safely press against the backside of the free-spinning second gear. Pressure on the main output shaft with the second gear backed up will free the splined first-second reverse hub from the shaft. The second gear rides on a needle bearing. This use of caged needle bearings at gear running surfaces is high quality. Another impressive feature of these Aisin transmissions. Second gear caged needle bearing slides off the main output shaft. Although costlier than transmission types that rely on hard metal to shaft surfaces to resist wear, the AX15 features hard gears, hard roller bearings, and hard shafts. The rollers reduce friction for some gains in energy efficiency. Their main purpose, however, is a long-life transmission with replaceable bearings. Although in some ways costlier to rebuild, these transmissions have a high reliability factor. The third, fourth gear Synchronizer Hub is held in position with a snap ring. Note again my use of heavy-duty snap ring pliers. Ring-eye, light-duty snap ring pliers will not do a good job on these heavy-tension transmission-type rings. Do not stretch snap rings more than enough to clear the groove. Avoid distorting these rings. Again, the spline's Synchro hub will require the press for removal. The same fixture serves well here, using the third gear as the backer for loosening the Synchro hub. Do not damage the gear. Keep fixture platforms outboard of the main output shaft machine thrust. Note that I catch the back of the gear only. Press carefully against the nose of the main output shaft. The hub assembly will come free and the shaft drops. Catch the expensive shaft. Here is the 3/4 synchronizer assembly, 3rd gear and the cage needle bearing. Keep these parts in sequence for inspection and reassembly. If you intend to reuse any synchronizer parts, note their location and positions, especially the brass synchro rings in the hub. 3rd, 4th synchro rings generally do not take the abuse of 1st, 2nd gear rings. I replace the 1st, 2nd synchro rings, but often reuse the 3rd, 4th rings if there are no signs of wear and they function properly. These are proven, durable parts. Make note that replacement parts must match the originals. There is a great deal of controversy about which synchronizer rings replace the late AX15 transmission parts. In the late AX15 transmissions, a unique design of synchronizer ring must be matched. For further details, go to forums.4wdmechanics.com. Work on the counter gear begins with removal of the snap ring that holds the front bearing in place. Heavy-duty snap ring pliers make quick work of this task. A 2-jaw, thin-jaw puller will grasp the backside of this bearing. Note that my puller has lateral bolts to prevent the jaws from spreading. This is a universal puller that works well in tighter spaces. The jaw ends are thin, flat, and somewhat broad, optimal for this bearing in its close proximity to the gear. I grease the threads to reduce friction and use an impact socket with light airgun force to carefully remove the bearing. Keep the puller from rotating when applying pressure to the screw. The front bearing of the counter gear, the selective fit snap ring, and the thrust washer, which is still on the shaft here, are visible. Check each of these parts for wear. Measure the thrust thickness and inspect it for wear. If you replace the snap ring, do so only with a ring of the same thickness, or thicker if the groove and ring indicate play. This is critical to counter bore and bearing alignment. Remove the front input bearing snap ring. You can see that this snap ring pliers has seen some duty. I have even notched and modified its bill to suit unusual applications. Despite removal of material, the quality steel of this tool keeps it intact. If you do a lot of transmission work, invest in transmission snap ring pliers with stout jaws. Pressing the front input bearing from the input gear requires a fixture. My fabricated fixture works well once more. The force is solely against the backside of the bearing. When removing a bearing in this manner, a great deal of force against the balls or rollers takes place. It is assumed that if you remove the bearing, you will replace it. When installing the new bearing, press only against the inner race. This will prevent loading the rollers or balls within the bearing. Here it is. This is the AX15 apart. Every piece is visible except the extension housing. The extension housing mount pad and mount threads had damage, and I will be replacing that section with a good used piece. See evidence of the damage to this housing later. As noted, this is a very busy transmission. Small parts and hardware, special fasteners and critical pieces, these are the crucial parts that need careful tracking. Account for each of them and set the pieces safely aside. You will need each and every one of these parts during assembly, as I will share in detail. Each of these parts should be checked closely for wear. You do not want to reopen this transmission anytime soon. Do not try to save money by reusing a damaged part. Use good judgment and recall how these parts performed when shifting, under acceleration, and under load in each gear. What you heard and felt is now laying on the bench. This is the time to fix the problems. This is a simple fix for electrical insulation grommets that have deteriorated. Starbright liquid electrical tape cures to a tough, insulation-like material. Use adequate ventilation with this stuff, avoid the fumes, and clean the surfaces before applying. You can layer several thin coats to the wire or insulation as necessary. This backup light switch is still in good working order. Cleaned up with fresh insulation on the grommet, it will likely last another 20 or more years. Inspect input and other snap rings and check their widths. The width is the selective fit measurement. Press the brass rings against the conical gear hubs and check for secure braking action. The ability of the synchronizer ring to grip the hub of the gear is what synchronizing gears is all about. Check bearings for roughness after washing them thoroughly. Spin bearings by hand only, feeling for play, listening for noise, and looking for etching or signs of wear or damage. These needles are slightly blue, a sign of fatigue and heat exposure. I will replace these bearings. These are all wear parts: fork edges, hub and sleeve grooves, rails, bores in the case pieces, arms, links, and levers. Each is a wear point and demands close inspection. Again, this is a time to replace questionable parts. Bearings should always be checked and compared to a new bearing if necessary. The reverse idler gear, oddly enough, rides on a bushing instead of a needle bearing. Wear at the bushing or shaft is cause for concern and will create whine in reverse gear. While this sliding reverse gear is only engaged in spinning during reverse operation, it does wear. Look for gear tooth damage and bushing wear. The bushing is not a service item. Wear demands replacement of the gear and bushing together. These cases were extremely oxidized and looked terrible. There was nothing wrong with them, however. I once again used my commercial glass bead blaster and with an hour's effort returned the cases to like new appearance and function. Make absolutely certain that no glass bead material remains in bores, crevices, or castings. I thoroughly washed and flushed these housings after blasting. It's hard to believe these are the same castings. Here is the original extension housing. This AX15 core came with a broken pedestal and one thread section missing. Although the YJ Wrangler uses only 2 of these 4 bolt holes, I elected to find a good used adapter extension housing. Note that the threads are damaged, with bolt holes wallowed out. Aluminum threads can be repaired readily with helicoil or timesert steel thread inserts. This would be my next step if I were reusing this housing. Aluminum simply will not tolerate abuse, especially over-tightening of bolts or cross-threading. Here is the 5th gear synchronizer sleeve, inserts and retainer springs. Inside the sleeve are the Synchro insert plates from the other synchronizers. These inserts are inexpensive and available. Replace them if there are signs of wear. Inspect all Synchro sleeves and Synchro hub teeth for wear, excessive play, and damage. Replace questionable parts. Measure all thrusts and snap ring widths. This dial caliper is very accurate to less than 1/1000th of an inch and is a quick means for identifying wear. Clean parts before checking thicknesses. If wear is evident or excessive, and if clearances are too wide, you can replace these thrust washers to close up measurements. The main output thrust that is built into the shaft would require shaft replacement if worn badly. This is highly unlikely though, and most worn shafts are the result of poor lubrication or bad bearings. The front bearing snap ring is a selective fit. This width controls the location of the gear and the tight fitment of the bearing against the gear. The rule here is to always use a snap ring that will completely fill the width of the groove. You must keep the bearing flush against its stop. If the snap ring is loose or shows clearance in the groove, replace it with a thicker width snap ring. This is not likely at the front bearing, as the bearing is a firm press onto the shaft, and the snap ring simply keeps pieces in place. Use the original width snap ring as a starting point. Check shafts for runout and true. A pair of V-blocks will support the shaft as you rotate it. Use a dial indicator with a roller end if necessary. Here, I'm using a non-roller end to get initial measurements. When switching to the roller end, I can rotate the shaft and check the amount of runout. Maximum allowable main output shaft runout is 0.0024 inch, a relatively small amount if measured with the V-blocks placed at the shaft ends. Less than this amount of runout is desirable and expected. This is an extra step for using an Advanced Adapters Atlas II transfer case behind the AX15 transmission. Installation calls for removal of 1/8 of an inch of material from the end of the output shaft. This is 0.125 inch. Several commercial tools will accomplish this: an industrial liquid-cooled bandsaw, a belt sander, a lathe, or a surface grinder with a holding fixture. I elect to use my reliable chop saw with a fresh blade. There's a caution here. I avoid forcing the cut, as this would heat the metal and destroy the original and essential heat treating of the shaft and splines. My commercial tool of choice would be a liquid-cooled bandsaw if there is enough material to allow the blade to make a groove and not run off the end. Operate the bandsaw at a slow cutting rate, slowly moving the blade to avoid overheating and deflection off the end of the shaft. I gradually work my way through the shaft. Check measurement often. If you use a cutoff saw like this, watch for signs of heat discoloration. Move the blade up and down frequently to keep the cut true. The blade will want to move outward with an end cut of this kind. I spent half an hour slowly cutting this end, patiently allowing the blade to find true alignment and watching the sparks to determine material resistance and the amount of heat applied. As a warning, protect the heat treating. Check the degree of heat frequently with an infrared surface temperature meter or gun. Always wear goggle-type eye protection when working with cutting or grinding equipment of this kind. Yes, this is really the same shaft. After cutting the end flush and squaring up the face, all with a chop saw, there were no signs of bluing. I used my bench grinder and platform to very carefully chamfer the spline teeth in a uniform, lightly raked pattern. This will enable easier transfer case input engagement during fit-up. The material grinds easily, so if you attempt to do this, use extreme care and a steady hand to bring the shaft to the grinder and rotate the shaft uniformly at the same time. Make sure the angle is also the same. A belt sander would be a practical alternative. Note, this finished shaft measures square, and there is no risk of an imbalance from removing material this far back from the rear bearing. There is no bluing or indication of heat impact on the shaft end. Uniform chamfers make the spline ends nearly identical to the original shaft, although I made a steeper rake to minimize the amount of material removed from the splines. If you are not sure of your tooling or ability to do this, consider subletting the task to a machine shop. If you install an Atlas II transfer case, follow the most up-to-date instructions from advanced adapters before modifying expensive parts like an output shaft. Take measurements carefully for a correct and safe fit-up of the transfer case input. Once you have cleaned and inspected pieces, order the necessary new parts. In the following illustration, these are the must-renew items, each replaced during a thorough manual transmission rebuild. This unit had over 200,000 miles on it. The must-replacement items for any high-mileage transmission include all bearings, Synchro springs, seals, nylon parts like the shift lever bushing, Synchro insert plates, the shift boot tower seal, and the Synchro rings that are worn. I always replace the first, second gear rings as a matter of course on a 5-speed manual transmission. There was no appreciable wear on the 3rd, 4th, and 5th gear brass rings, and they tested to specification. This is common, and I reuse these unworn Synchro rings. Assembly sequence is critical to the AX15 and other modern transmissions. They have way too many interrelated parts unless you have thoroughly learned the procedure outlined here or within a factory workshop manual covering the AX15. You really need to use this guide. Getting creative and cutting out steps will not work either. The steps I outline here are proven and the fastest way to properly rebuild the AX15. With an AX15 on the bench, my time to disassemble, clean, inspect, and reassemble the unit is 2 to 3 hours, excluding the time out for getting parts, blasting corroded cases, modifying main output shafts. I know which tools to use, how air tools can save energy and time, when the hydraulic press is necessary, how to wash some parts while disassembling other sub-assemblies, the typical time-saving measures of any flat-rate professional truck mechanic. If you do enough of these units and have the right tools, you will reach such a pace. The first AX15 rebuild will take much longer for anyone. As we move forward, have you cleaned all parts thoroughly? Checked for warp, wear, and scorching? If you have lined up the pieces that need replacing, let's get to work. The first step involves the hydraulic press. Use a sleeve that will just clear the input shaft. Press the bearing at its hard inner race. Do not allow the sleeve to contact the seal of the bearing. Make sure the outer race of the bearing rotates freely while installing the bearing. I hold the jack handle with a reasonable load when the bearing seats. Make certain the bearing is securely against a clean, flat bearing stop on the input shaft. There is no need for an oil slinger with this type of sealed bearing. The snap ring groove should be visible. The original ring should fit the groove, or you have not pressed the bearing fully into place. Here, a snap ring of the same thickness as the original fits perfectly in the groove. This snap ring groove seldom changes shape. Bearings like a quality NSK fit exactly and meet the original dimensions perfectly. Always buy quality bearings. The front counter gear bearing will require force to install. Note that the bearing is a three-piece arrangement. The thrust fits at the back of the bearing as shown. The insert inner race fits inside the rollers. I drive the bearing into place. The impact socket fits neatly over the shaft and taps against the inner bearing race. Force must be against the inner race only. Note the block of wood supporting the bottom of the counter gear cluster. A slight amount of grease on the shaft and the bearing moved into place with just the use of a plastic sandhead hammer. More force than that, and I would be using the hydraulic press. Install the lock ring with channel locking pliers. The conventional snap ring pliers will not work well here, as the gap in the ring's opening is too large. Make certain that the lock ring seats completely and is tightly secured in the groove. This applies to all snap rings, C-clips, and E-clips. These rings must not loosen in service. I coat the seal bore of the retainer with Super 300 sealant, a uniform film around the bore wall. Use a suitable driver or a socket that will fit safely between the inside of the seal jacket and the spring-loaded seal lip. I drive evenly with a sandhead hammer, checking constantly to keep the seal square in the bore. Tap very lightly, or you may drive the seal too far. I grease and install the input shaft in the seal to confirm seal lip contact points. This is the correct seal depth, exactly where the seal ran before. As a caution, this seal should not be driven to the base of the retainer bore. The best criteria for setting the seal depth is by placing grease on the sealing surface of the shaft. I check alignment of the seal's double lip by fully seating the input shaft. Check often as you drive the seal into position. I happen to have a driver that works well for the extension housing seal. The bore coated with Super 300, I drive the seal carefully. The goal is to seat the seal in its original location or flush with the bore's face. This places the top of the seal in line with the bore face. Mating this transmission to the Atlas II transfer case input, I set the seal just slightly deeper, aligned with the lower edge of the chamfer at the outer end of the bore. Always grease the seal lip recess with quality chassis grease. This applies to the front bearing retainer seal as well. This will protect these seals during initial startup. Within the extension housing is the reverse pin. If you need to clean, service, or replace the reverse pin, remove the plug at this section of the case. I am demonstrating how to access the roll pin if you need to service the reverse pin. You can access a spring roll pin in this way. The reverse pin is readily accessible in the extension housing. Once the spring roll pin is driven through the shaft, you can remove the assembly. I am sharing this information to help clarify how the reverse pin comes loose. Inspect the spring tension and free movement of the reverse pin mechanism. This device is very durable, and unless damaged, it will continue to offer service for a long time. At right is the first gear, and at left is the second gear, plus the synchronizer pieces, each in their order of assembly. The synchronizer's outer sleeve doubles as the reverse gear. This is a busy and important assembly. Inspect the parts carefully after cleaning them. The first second gear synchronizer assembly gets a workout on Jeep YJ and TJ Wrangler 4x4s. Note that I am installing new brass Synchro rings and new insert plates and springs. Typical replacement parts are readily available for the AX15 transmission. Here, I detail how to assemble the first-second synchronizer. Begin by placing the sleeve in position. If you did not mark these parts for direction during disassembly, take note of the faint wear pattern on the hub's inner thrust faces. Match the direction of installation with these patterns. For the first-second Synchro hub, there are no other distinctions. Install the sleeve with the offset shift lever groove facing toward the front of the transmission. Install the 3 inserts and 1 spring exactly as shown here. I spin the hub 180 degrees and install the second spring exactly like the first. The aim is to have the gaps in these springs facing opposite each other. Since there are 3 inserts 120 degrees apart, it is impossible to have the gaps exactly 180 degrees apart. This is the correct installation. Note how I place the spring ends just beyond the insert plates. Be sure that the plates, springs, hub, and sleeve align properly. The springs will seat against the hub face when the Synchro rings fit into place. Here, the brass Synchro ring is in place. Notches align with the inserts. The synchronizer ring keeps the spring against the hub face. I oil the new brass ring's cone-shaped braking face with 75W140 Mopar synthetic gear lube. Just a film for now. If you do not oil these pieces, they could stick during initial run-in and cause balking shifts. These brass blocking or synchronizer rings are crucial to proper shifting. Note the distinction between the wear pattern on this inner hub thrust surface and the opposite side shown in the last illustration. I use this as a final confirmation of the direction that this hub should face. With a new first-second gear synchronizer hub, match the direction of the old hub or note the inner spline's slight recess and ramp that faces forward. The rearward-facing side of the hub has flush inner splines. Used parts in a transmission that has not been apart before have an established wear pattern that serves as a guide for fitment. New brass rings and springs can go at either side. First-second synchronizer plates are reversible too. This is a first-second gear assembly together. Note that the second speed gear is to the left, the first gear to the right. The synchronizer sleeve has outer teeth. This is the reverse gear. A 5-speed overdrive has limited space, and this is an effective way to establish a reverse gear. The synchronizer hub supports the first, second, and reverse gear functions. This is a considerable load and requires strong parts with close tolerances. This is a third, fourth gear synchronizer assembly. Distinguishing features determine its fitment and the relationship of parts. To the front, this synchronizer engages the input gear and drives power directly through the input to the main output shaft. To the rear, the sleeve engages third gear, using the cluster counter gear as a means for reducing speed and increasing available torque. Look closely at the synchronizer hub. The inner hub has a chamfer that faces toward the front of the transmission. A chamfer on the outer sleeve also faces forward. There is no chamfer at the rear of the hub. Note how I inserted the plates and springs. The ends of the spring overlap 2 of the plates. This is a configuration for first, second, and third, fourth gears on the AX15 transmission. Here I have pivoted the assembly exactly 180 degrees as I did before. Note that the spring appears in the same location as in the last illustration. This side of the hub has no inner chamfer and faces rearward. The gap between the 2 spring ends is as nearly opposite as plates spaced 120 degrees apart will allow. If I pivot the hub 180 degrees to see the opposite side of the hub, the spring will once again appear in this location. This is the spring and plate arrangement and how it should appear at opposite sides of the hub. I am holding the synchronizer assembly in place. The chamfered inner hub and outer sleeve both face forward. Brass Synchro rings keep the springs and plates seated. This is not a complicated setup. If you follow the steps closely, especially the spring and plate locations, the transmission will shift properly. Synchro assemblies properly together, the process moves along. Install the new needle bearing for third gear. This should slide onto the main output shaft in front of the built-in machined thrust. Note that the bearing ends flush with the shoulder and fits properly on the shaft. Oil the bearing lightly with 75W140 gear lube and slide on the third speed gear with Synchro ring. This should all go together easily with no friction or resistance. Do not force any parts. I use a press to install the Syncro hub and Synchro assembly, not only to ease installation but also to avoid jarring the synchronizer assembly. Note that I am supporting the third speed gear and its brass Synchro ring to keep it in position as the hub comes down. The intent is to keep the brass ring from dislodging, which could allow the spring and plates to come loose. You can also do this by aligning the Synchro ring with the plates as these parts come into contact, pressing on the hub very slowly to avoid crushing or damaging the brass rings, plates, or springs. As a warning, do not move the synchronizer sleeve, or the plastic plates and springs could come apart. This applies to the assembly even after all parts are in place. Keep the sleeves centered and facing in the correct direction. If you follow the approach that I illustrate here to seat the hub on the main output shaft, always use extreme care. Do not pinch your fingers. Make certain that the holding fixture will keep the shaft and gear assembly from shifting or coming apart under load. There is always risk when working with the forces of a hydraulic press. Move the hub slowly, watching for any irregular movement as the hub moves down the shaft and into position. Stay out of harm's way. Place the selective fit snap ring in the groove. It should fill the groove snugly. If there is side play in the groove, purchase a larger snap ring to fill the gap. One size does not fit all. Use the original snap ring width as a guide. Increase width from there as needed. Make sure all snap rings seat completely and securely. Here I make a final check of clearance between the gear and the main output shaft built-in thrust. You should be in the 4,000th inch to 10,000th inch range. This reads a snug 8,000ths of an inch. Very acceptable for a transmission that has 200,000 plus miles on it and came from a 1990 XJ Cherokee, the same unit used in 6-cylinder YJ Wranglers from 1989 to 1995 and the 4-liter TJs through 1999. The main output thrust and gear sideware is negligible for this kind of mileage. I did not need to replace a single gear, hub, thrust washer, or shaft. Here I slide the second gear needle bearing into place. New bearings are good insurance for a backcountry YJ or TJ Wrangler transmission. Second gear slides over a lightly oiled bearing. Note that the gear hub lines up flush with the end of the bearing. The bearing and gear line up with the shaft step shoulder for the first-second gear synchronizer hub. Now I press the first-second gear synchronizer assembly onto the main output shaft. Note how I once again support the lower synchronizer ring as my press is stable and safe. If there is the slightest doubt about your safety, stay away and move the hub slowly, aligning the lower brass Synchro ring with the plates as these parts come into close contact. Do not damage the brass ring. Install the snap ring onto the main output shaft. This secures the Synchro hub for the first-second gear. The fit should be snug with no side play of the selective fit snap ring. While a screwdriver might work for this ring installation, I find that channel lock pliers work better. When using a set of pliers, do not chew up the ring, shaft, or any other parts. Use care and place duct tape on the pliers' jaws if necessary. There is a nylon spacer that goes between the Synchro hub snap ring and the first gear bearing. If installed correctly as illustrated here, the needle bearing will be near flush with the shoulder step of the main output shaft. Excessive wear on the spacer will cause bearing misalignment and too much bearing end float. If that is the case, install a new spacer. Install the lightly oiled Synchro ring on the first gear side of the hub. Keep the sleeve reverse gear centered on the Synchro hub. Install the first speed gear and make sure it fits flush with the Synchro hub's thrust surface. There should be no resistance as the gear slides over the new, lightly oiled bearing. This is the tiny pin that flew out of the main output shaft during the high-pressure parts wash. Fished from the floor of the washing cabinet, this pin goes in place now. The thrust washer will keep it in place. Slide the first gear thrust into position. Note the wear pattern and install the piece in the same direction as the original installation. Keep the thrust in position while installing the output bearing. If necessary, use petroleum jelly to glue the thrust washer to the first gear thrust face while installing the bearing. One way to keep the thrust washer and pin in place is to stand the assembly upright for pressing the bearing onto the output shaft. The hydraulic press makes quick work of this process. Always use a sleeve that presses only on the inner race collar of a new bearing. This will prevent stressing and damaging rollers, ball bearings, races, or plastic shields. Lightly oil or grease the shaft before pressing the bearing into place. The new bearing fully seated, you can check the side clearance of the first gear. Place a blade feeler gauge in the slight gap between the thrust washer and gear. Allowable clearance is 0.003 of an inch to 0.0197 inch. I can hardly get a 0.016 inch blade to fit, a healthy sign. The actual clearance is between 15 thousandths and 16 thousandths of an inch. Once again, impressive for original parts at this mileage. Aside from the wear impressions, you can use the beveled internal splines as a guide. This side of the fifth gear goes on the output shaft first. Look closely, and you will see the snap ring impression at the outer end. This will serve as a guide for a unit that is original and not previously rebuilt with questionable workmanship. Slight bevels help the splines engage. The fifth gear will supposedly tap into place. I find that the AX15 spline engagements are a precise interference fit. A press is the most sensible approach here. Lightly oil the splines and use a suitable sleeve to clear the output shaft. Seat the gear snugly against the output bearing's inner race collar. The snap ring should always fit snugly in the gap of the groove. Here, the ring is accessible and a tap with the plastic hammer drives the ring onto the shaft. Check the snap ring for tightness and fit. It should be secure on the shaft and not rotate easily. With this kind of ring, I want to feel a bit of resistance when rotating the ring. Make sure it seats all the way around. Oil and install the new pilot roller bearing. The bearing fits the back bore of the input shaft and accepts the nose end of the main output shaft. There is no need for thrust washers, as this rugged bearing has thrust ends and is fully self-contained, unlike free-floating needles and washers used on many transmissions. Install a new pilot bearing in the crankshaft, and if the transfer case input is stable, the shaft alignment of the input and output should remain true for a very long and productive service life. Place the fourth gear brass synchro ring in position. Slide the input gear into position, making sure the lightly oiled synchro rings are in place. This is the input main output shaft assembly. Note that this entire assembly needs to go into the intermediate plate together with the aligned cluster counter gear. Keep the synchro sleeves centered as you handle this lengthy gear assembly. I set the intermediate plate securely in the bench mule fixture. Here the cluster counter gear rear bearing goes into the case. I tap gently at the outer race of the bearing. The snap ring came with the new bearing and matches the thickness of the snap ring on the OE bearing. Note that the cluster shaft surface serves as the inner bearing race. Make sure the shaft journal does not show scoring or visible wear. If in doubt, measure for out of round with a micrometer. As a caution, if you do not have a fixture like the bench mule, you will need to support the intermediate plate in a bench vise with protective rubber or aluminum covers over the jaws. Do not gouge or mar the aluminum. There will be a good deal of weight on the intermediate plate. You may need assistance loading these two shafts together. They must remain aligned and uniform as you insert them into the intermediate plate. I did this by myself, finding fortunately that the fit is excellent. Once the cluster shaft engaged the rollers of the lightly oiled new bearing, I tilted the whole assembly upward to align the output shaft bearing with its bore in the plate. Shafts aligned, straight and level, I'm able to push them into the plate far enough to support some weight. Continue to keep the gear assemblies aligned. To suck up the rear bearing on the output shaft, Tap gently at the intermediate plate just outboard of the output bearing. Use a sandhead plastic hammer as you see here. Tap while applying rearward pressure to the gear sets at the same time. The bearing will work through the plate, exposing the snap ring groove. Shafts and gear teeth should remain in alignment throughout this process. Do not force parts. This is a precise assembly, and when all is right, the parts do fit. Install the snap ring on the output shaft bearing. Make sure that both the output shaft bearing snap ring and the snap ring on the clustered counter gear bearing are in position and seated fully. Install the reverse idler gear by moving the lightly oiled shaft through the intermediate plate and the gear. Note the direction that the gear faces and where the shaft alignment groove sets. Do not install the gear backward. Align the shaft slot with the rear bearing retainer plate tab at the back face of the intermediate plate. The rear bearing retainer plate should fit flush against the intermediate plate. The tab at the lower left engages the reverse idler shaft slot. Engage the plate in the slot. Use Loctite 242 blue on the bolt threads and tighten the 4 plate bolts. Torque specification is 13 foot-pounds. I prefer 14 foot-pounds. Let hardware set for a few minutes after tightening and recheck the torque. On the reverse shift rail, you will find a slot for one of the small interlock pins. Petroleum jelly will hold these parts in place during fit-up. This is the only way to hold several of the interlock pieces in place during the assembly. Use a generous quantity. It will dissolve later in the transmission oil. Center the interlock pin. The reverse shift rail goes in the second bore from the bottom. Slide the rail through the bore. You can C-clip the rail once in position. I prefer to wait until all rails are in place. If you do not install the C-clip at this point, keep the rail's fork against the intermediate plate. This will help prevent the interlock pin from dislodging. This is one of several ball bearings involved with the interlock system. Without petroleum jelly, this ball will simply not stay in position. I bring it into the bore below the reverse rail and insert the ball with the assistance of a screwdriver. The ball rests in the passage above the lowest rail bore. Gravity challenges this goal. The larger interlock plug can drop through the vertical passage. With a magnet and lots of petroleum jelly, I slide the interlock plug into position above the reverse shift rail. There is one more small interlock pin. It fits in the first-second shift rail. Find the slot and insert the plug with a coating of petroleum jelly to keep it in place. Center the pin to keep it out of the way during installation of the rail. Note the use of a small magnet to make this job easier. As you slide the first-second shift rail through the intermediate plate, make sure the interlock pin stays in place. Catch the lower hole of the first-second shift fork as the rod slides into the gear set area. When attempting to slide rods through, you will discover the value of rotating shafts and sliding them in ways that allow their deeper grooves to permit balls and interlock pins or plugs to move out of the way. Never force these parts through. There is always a just right position that permits fit-up. Keep track of the balls and interlock pins or plugs. Make sure they remain in position as you adjust and position the rods. Here's one more interlock plug. Coated with petroleum jelly, the plug drops down the vertical slot. I use a pencil magnet for this purpose. The plug lodges just above the first-second shift rail. Make sure the interlock plug seats. Now the third-fourth shift rail slides through the intermediate plate. It picks up the upper hole in the first-second shift fork before reaching the third-fourth shift fork bore. Lift the third-fourth shift fork to align the rod bore. Slide the shift rail through the shift fork's bore. Note the direction that these two shift rail levers face. In the final position, their shift slots face toward the shift tower and shift lever. The next illustrations show the relationship of the two rods and the shift forks. Use Loctite 242 on all threaded hardware. The special set screws for the shift forks thread into the shift rails. These two shift fork screws torque to 14 foot-pounds. Loctite will eliminate risk of this hardware loosening in service. Let set screws set for a few minutes and recheck the torque. Each of these 3 rails has a C-clip lock. Make sure these locks fit securely and seat in their grooves properly. You do not want loose parts or the risk of anything coming apart in service. Take the time to secure these clips properly. Slide the 5th gear rail, the lowest of the 4 rails, through the reverse shift fork's lower bore and through the bottom bore in the intermediate plate. This will keep the lock ball in position below the reverse shift rail. The 5th gear rail need only pass through the intermediate plate enough to hold the lock ball above the 5th gear shift rail. This interlock ball serves between the 5th gear rail and the reverse shift rail. Move to the back of the intermediate plate. The 5th gear thrust ring fits on the output shaft. There is a ball lock that fits in the shaft. Install the ball with petroleum jelly and place the thrust ring with a broad surface facing rearward. When in doubt, observe the wear surfaces and match the parts up. This general rule applies to any OE transmission that has not been disassembled before. Here is the 5th gear synchronizer mechanism. This spring and insert plate arrangement is unusual. The 2 Synchro rings fit on the same side of the Syncro hub. Note how they overlap and tension the plates. Note too that the plates only fit one way. The 180-degree turnaround reveals the back view of the Syncro assembly's insert plates and sleeve. The sleeve goes on one way. The plates fit in one direction, and the 2 springs overlap at a plate to keep them from rotating. Note that the beveled engagement splines of the Syncro sleeve are now at the opposite side, facing the brass Syncro ring as shown in the last illustration. Assembled synchronizer and hub shows the plates in position and the springs overlapped at this plate. The brass Syncro ring will keep the springs in position against the hub face and also lock the insert plates in position. This is the entire counter 5th gear and synchronizer assembly ready for installation on the cluster counter shaft. The 5th spline gear is lying in the foreground. Lightly oil the parts and the bearing surfaces. Make sure the brass ring has a light coat of oil on the contact surface with the gear hub. Oil will prevent drag upon startup of the newly rebuilt transmission. The bearing at the counter 5th gear is unique. No, this is not defective. The bearing actually has a split, 2-piece cage. Grease the bearing with petroleum jelly or oil it with Mopar 75W140 oil. This will prevent friction and a dry startup. Lube guard is a good lubricant to use during transmission assembly. 5th and counter 5th gears are now aligned and engaged. This is the 5th gear overdrive system. The brass synchronizer ring is similar to the rings used at the 3rd, 4th gear Syncro assembly. At this stage, the 5th spline gear must go in place. While it is suggested that the spline gear will tap onto the cluster counter shaft, this may not be possible. I prefer not to exert much pressure on the counter shaft at this point, and setting the assembly in the press would be awkward if not impossible. I elect to use a deep set impact socket, an old 1/2 to 3/8 inch adapter, and my air driver with a blunted chisel point. This approach will dance the spline gear onto the lightly oiled shaft splines while I hold the synchronizer brass ring in place. I am applying minimal force to the counter cluster gear shaft while backing the shaft up solidly at the opposite end. As a caution, when driving the 5th spline gear onto the cluster shaft, make sure the opposite front end of the cluster gear is supported rigidly against a block of wood. You need to place the block against a solid vertical backup. Keeping the cluster counter shaft from moving forward will prevent damage to the rear cluster bearing. Unscathed, the 5th spline gear is now in position. You can install the snap ring, which should fit snugly within the groove. Seat the ring fully and make sure it has good tension in the groove. You do not want these parts to move out of position in service. The splines make a tight fit of the 5th spline gear to the cluster counter shaft. Now you can install the reverse shift head and rail. Note its relationship with the long shift rails and also the position of the shift head. With the assembly in position, install the locking ball below the rail. This ball will fit above the lowest 5th gear rail, interlocking between the reverse shift head's rail and the 5th gear rail. Use petroleum jelly to keep the ball in its bore. The 5th gear rail is barely through the intermediate plate at this stage, keeping an interlock ball in place at the plate. Now I slide the 5th gear shift rail through the reverse shift head bore. Note that the rail must fit with the interlock notches facing in the correct directions. The shift fork receives the rail, and the set screw locks the rail in position. Note the chamfered edge at the set screw thread in the rail. This faces the screw, aligning the rail's notches properly. Use Loctite 242 blue on the screw threads and tighten the screws securely. Always use a torque wrench for final tightening. This time the figure is 15 foot-pounds. You want these shift forks to go another 200,000 miles or more in position. Recheck torque after hardware sets for a few minutes. These 3 interlock bores reveal the notched recesses of the rails. With all Synchro sleeves in neutral mode, the rails should align properly as shown. These bores each take a ball and spring, retained by the plug. Balls go in place with petroleum jelly. All shift interlock balls are the same diameter. The only ball of a different size is the one that locks the thrust ring at the cluster counter gear output behind the rear bearing. This ball is noticeably smaller. The lock ball springs are each the same length, except the one that fits at the extension adapter housing, a simple enough strategy. Note that the correct length springs all fit out to the edge of the bore. The one shorter spring will not. Save it for the extension housing's detent spring location and detent plug as illustrated further along in this assembly process. Use Loctite 242 blue on the outer plugs. They will require a Torx bit to tighten. These plugs are each the same size and thread. Use Loctite in a manner that will secure and help seal the plug. In aluminum, Loctite 242, which is medium strength blue, is appropriate. Do not use Loctite 271 high strength red on aluminum threads, as you will risk pulling threads loose upon disassembly the next time. I use 242 throughout the AX15 transmission assembly. Final tightening is always with a torque wrench. 14 foot-pounds is the specification for these plugs. After tightening, allow them to set for a few minutes and recheck torque. A quality Torx bit set is my recommendation if you perform this kind of work often. For work on a Jeep YJ/TJ Wrangler or XJ Cherokee, a full Torx driver set is imperative. Move to the reverse shift linkage. Install the E-clip at the reverse shift arm and shift arm bracket pivot. Some do this after installing the bracket. I perform this task first. Make certain that the E-clip seats securely and will stay in place. Mesh the reverse shift arm engagement block with the reverse idler gear groove. This block must remain in place when you install the reverse shift arm and bracket. After installing the bracket, make sure the block is still in this groove. Apply Loctite 242 blue to the bolt threads for the reverse shift arm bracket. Carefully install the bracket, keeping the shift arm engaged with the reverse idler gear. Once the assembly is in place, secure these 2 bolts with a torque wrench. The specification is 13 foot-pounds. I torque to 14 foot-pounds and recheck torque after several minutes. This is the final view of the shift rails at the rear of the intermediate plate. Note the relationship of the shift rail levers with a pocket among them to receive the shift arm. Look over your handiwork and make sure your transmission shows these components in place. Here is the shift rail and gear set view forward of the intermediate plate. Make certain your transmission assembly has each of these pieces in place and sequence. Note shift linkage for the reverse idler gear and the shift forks. Use this illustration as your reference. On left-hand drive models, this is the full driver's side view of the assembled gears. On a transmission this busy, the sequence of assembly is essential. Look closely. You simply cannot leave out or skip steps. Note the reverse idler gear and the block riding in the reverse idler gear groove. Use this illustration as a reference. Now I take the intermediate plate loose from the bench mule. If you are using a bench vise with cushioned jaws, remove the complete gear and plate assembly now. Tilt the unit to make the front side of the intermediate plate accessible. support the rear of the assembly safely to prevent damage or dislodging any parts. Clean and dry the intermediate plate faces and main case face. Make sure there is no oil or residue on the mating surfaces and that the two dowels are in place and in good condition. Apply a bead of appropriate sealant to the clean and dry intermediate plate surface or the face of the main case. A 1/8 inch bead will suffice. It will spread when the plate and case contact each other. Sealant winds inboard of the bolt holes for maximum sealing. You do not want leaks. Note that the original factory recommended sealant was Mopar Gasket Maker, which is an anaerobic type sealant. Another factory recommendation has been 3-bond liquid gasket. Check with your local Jeep dealership to see what is currently recommended and used by the service department. I used a specified alternative here. Historically, Permatex's 518 gasket eliminator has worked well on aluminum transmission and transfer case housings where there is no gasket and an interference type machined fit. As busy as this assembly appears, if all of the rails, shafts, and bearings are in alignment, the front case will drop into position. Never force the parts. Guide the case onto the rails and front bearings, constantly watching the mating surfaces. Do not dislodge sealant prior to the case mating surface coming into contact with the intermediate plate. Watch the dowels to assure alignment. The front bearings will require coaxing of the case with a sand-filled plastic hammer. Light taps around the outside of the bearing bores will suck the bearings into position as the case drops into place. This should do the trick. If not, something is binding or out of alignment. The assembly is so precisely fit that cases come apart and assemble readily. Snap rings now go at the front bearing grooves. Make sure that they seat properly and fit snugly. Note the ghost line of original sealant at the case face. I cleaned this case with a glass bead blaster lightly and the sealant trace did not lift. It is not advisable to scrape aluminum, and the sealant trace is so thin that it will not interfere with either parts alignment or face-to-face fitment. I chose to leave it alone. Here is a sealant bead on the surface of the front bearing retainer. Make sure the seal is in place. A 1/8 inch bead of sealant will do here. Note that I line sealant inboard of bolt holes to assure a proper seal. Sealant will squeeze outward in both directions. I carefully set the retainer onto the case, protecting the seal. The lip seal recess has grease filling the groove. Align the retainer and set it directly to the bolt holes. Use Loctite 242 Blue on the bolt threads to secure and seal the front bearing retainer bolts. Note that advanced adapters can supply this iron retainer to convert from an earlier YJ or XJ hydraulic style throwout bearing to the later release arm with external slave cylinder approach. Tighten the bolts and cross until the retainer is flush. Then go around the circumference with a torque wrench a few times. Specification calls for 12 foot-pounds. I tighten this iron retainer to 14 foot-pounds on the final pass and recheck at 14 foot-pounds after a few minutes. This retainer supports the front transmission bearings and also the clutch release bearing. Fitting flush, squarely, and snugly is essential. Repeat the sealant application at the rear extension adapter housing. A 1/8 inch bead will suffice. More is a waste and will only make a mess as it squeezes out in all directions. Make sure the extension seal is in place with grease filling the lip recess. Be certain the two dowels are in place and in good condition. Dowels aligned with case holes, the extension housing should tap into place without great effort. Beading is not necessary and would indicate parts misalignment. I tap lightly in a rhythmic, circular pattern around the outer face of the housing. Keep parts straight and watch the mating surfaces come together. I install the backup light switch with a film of sealant on the threads and a new OE-type gasket before installing the bolt that holds the wire clamp in place at the extension housing. Note that I support the transmission at the intermediate plate to keep pressure off the installed extension housing. In one factory-level book, specifications call for 27 foot-pounds torque at the switch. Another factory reference calls for 32.5 foot-pounds. I use an open-end wrench to tighten the switch securely to the 30 foot-pound range. If you are not familiar with torque feel, a crow's foot, open-ended wrench-type socket would work with a torque wrench. 30 foot-pounds is plenty. These threads are aluminum. The backup light switch secure, I install the extension adapter housing bolts. There is a recommendation for sealant on these threads. Instead, I use a uniform coating of Loctite 242 on the bolt threads to make sure they stay put and seal. Size bolts carefully, matching the stick-out lengths to determine where they fit. Tighten and cross, making sure that the extension housing remains square with the main case as you tighten the bolts. Tighten the final torque with a torque wrench. The bolt torque specification is 27 foot-pounds for extension adapter housing bolts. Tighten in cross, then go around the 10-bolt pattern. Let parts set several minutes and recheck the torque. Note that when using Loctite 242 as a sealant thread locker, I take 2 matching bolts and place Loctite on one's threads. With the thread ends facing each other in parallel, I bring the threads together side by side and swirl the 2 thread sets against each other. This places an even, more uniform coating on the threads, highly effective and not wasteful. Try it. Install the reverse shift rail detent ball and spring. The ball is common detent size, however the spring is the short spring shown at right in this set. Note that the spring fits to the end of the bore. Use Loctite 242 on the detent plug threads to secure and seal the plug. Install the plug and torque to 14 foot-pounds. After several minutes, recheck the torque. Drop the last interlock ball into the top opening in the intermediate plate. The spring is the same length as the 3 interlock detent ball springs that fit the side of the plate. Use Loctite 242 to seal threads and secure the access plug. Tighten the plug to 14 foot-pounds with a Torx bit. Recheck after several minutes. This is the last ball, spring, and plug. Insert the shift arm shaft, its oil passage bore facing to the rear. The threaded set screw section of the shaft has a chamfer at one end. Install the shaft with the chamfered end of the threads facing upward. The shaft side oil hole will aim correctly. Here, the shaft fits through the shift arm's bore. I will rotate the shaft to align the chamfered end of the threads with a set screw hole in the shift arm. Engage the shift arm with the shift rail levers. Recall, there are 3 shift lever ends that form a pocket. The shift arm rotates and moves within the 3 levers. You can feel the arm engage the space among the levers. When aligned and centered correctly, the shift arm pedestal and the shift lever bore will face straight up. Adjust the shift arm shaft to align the chamfered end of the threads with a shift arm set screw hole. Install the set screw with Loctite 242 blue on the threads. This screw torques to 28 foot-pounds. Tighten securely with a torque wrench. Let the screw set for several minutes, then recheck torque. I coat the restrictor pin threads with a bead of sealant adhesive, not Loctite. Loctite on aluminum threads of this size could create a problem when removing these pins later. An appropriate sealant with adhesive properties will seal well and form an adhesive bond as security. Tighten restrictor pins to the minimum specified 14 foot-pounds. Here, I bring restrictor pins to near specification with a box-ended wrench. I will use a socket and torque wrench to verify final torque. Recheck torque with the torque wrench after pins have set for several minutes. I retorque to 15 foot-pounds. Coat the shift arm shaft plugs threads with a film of Loctite 242 blue. This will serve as a sealer and secure the plug well. The plug faces the cavity of the adapter, and a leak here would allow oil to seep out of the adapter extension housing bleed hole. Torque the shift arm shaft access plug to 14 foot-pounds with a torque wrench. Recheck torque after several minutes. By now, you know that I recheck torque. Hardware seats and settles Some mechanisms generate friction during tightening. A recheck of torque means this unit is secure and ready for a long service life. Coat each side of a new shift tower gasket with Super 300 sealant. Place these pieces carefully atop the adapter extension housing. I use Loctite 242 on bolt threads and run the bolts down quickly with a speed handle. Tighten and cross and evenly. Secure to a final torque setting of 14 foot-pounds. Let hardware and the gasket set for several minutes, then recheck torque. The shift lever and mechanism can be cleaned thoroughly and painted. The lever had rust that cleaned up nicely on the wire wheel. I installed a new plastic end bushing at the lever mechanism. The gloss black paint is rust resistant, a good idea for a Jeep 4x4. Grease the shift lever bore with light chassis grease. The nylon seat bushing will benefit from grease. I also greased the new nylon bushing that engages the shift arm. Install the shift lever spring. I coat this part with grease to prevent rust and friction. The spring fits this way. This retainer has slots on each side that engage the locating pins in the shift tower. Spring loaded, you can press down on the retainer, compress the spring, then turn the retainer clockwise until the lugs engage. Release the retainer and the spring will hold the pieces in place. This is the position of the retainer when seated. Here I have applied pure silicone spray to the shift boot center and very carefully slide it over the square end of the short lever. The boot will keep dirt and debris out of the freshly rebuilt transmission. Silicone spray is very handy for stretching rubber parts like this. Boot seated and secure. You can also see the new shift knob here. Fortunately, these parts are readily available to Jeep owners. The new front bearing retainer was unpainted. I used this rust-inhibiting paint to seal and prevent rust at the new retainer. This retainer will enable use of the external slave cylinder clutch housing and clutch linkage. The original internal slave release bearing uses a bearing retainer without the release bearing extension. 1993 up YJs and all TJ Wranglers use the external slave cylinder with the AX15 transmission. My last step is to measure the stick-out length of the output shaft. Stick-out is the amount that the shaft end extends beyond the face of the adapter extension housing. This measurement is 350 thousandths of an inch after my removal of material to accommodate the made-up to an Advanced Adapter's Atlas II transfer case. The stock stick-out length will of course be longer. This is the complete rebuild of an Aisin AX15 transmission. I'm impressed with the design and integrity of this gearbox. Quality new parts from the aftermarket or Mopar Jeep can restore the stamina and reliability of such a 200,000-mile-plus transmission. Here is a like-new Aisin AX15, ready to deliver years of trouble-free service, like your build-up should. Here is the right side of the unit. I ran the shift lever through each gear position, rotating the input shaft and feeling output speeds at the rear output shaft. This transmission shifts beautifully. Here is the left side of the freshly rebuilt AX15 transmission. The shift lever extension and new motor mount will install with the transmission. The AX15 transmission is a worthy, rugged, light-duty truck transmission that will readily handle the high-output 4-liter inline 6-cylinder power. In rebuilt or good condition, this transmission should handle 250 to 275 horsepower under reasonable four-wheel drive use. This can include smaller V8 engine power. If you want to raise the horsepower beyond this level, consider an NV4500 conversion. Contact Advanced Adapters for details. As a caution, remember that in any 5-speed overdrive transmission, 5th gear on the main output shaft faces the greatest load. Yet this is the smallest gear of the forward speeds. Use 5th gear prudently and avoid overloading or taxing the 5th gear. As an additional footnote, always replace the crankshaft pilot bearing when installing a rebuilt transmission. Be certain that the clutch linkage is in good condition. There are clutch upgrade options to match a high-output 4-liter or stroker inline 6-cylinder Jeep engine. Always be certain that the flywheel is in good condition. Resurface if possible. You now have a rebuilt Jeep Aisin AX15 transmission built to professional factory standards.